I'm Tech Adams. Welcome to my laboratories where we explore science through technology and technology through science. Today, we're putting limits on infinity to make things good enough. Imagine you have a distance to cross like that between me and this mailbox. If I walk at a constant speed from my starting point, I will eventually reach it. Let's say that it took me only 3 seconds to walk 10 feet to the mailbox. Or we can look at it a little differently. Rather than looking at the distance as a whole, we can look at it as a series of halves, where every time we reach the halfway point, we start over our counting of distance. So, first I cross the first half of 5 feet in 1.5 seconds, and have 5 more feet between myself and the mailbox. Next, I cross the second half of 2.5 feet in 3/4 of a second, then the third half of 1.25 feet, and so on and so on. I can keep up this pattern to infinity, constantly covering only half the remaining distance in half the remaining time, and thus never actually reaching the mailbox. But the problem is, at some point, I do actually reach the mailbox. I cover that last remaining distance, and math says that this is impossible, unless I reach a distance that is indivisible, a length that cannot be cut in half, a limit on infinity. The process of taking an infinite number of values and reducing them to a small set of fixed values is called quantization. This 12-letter word, worth between 30 and 369 points in Scrabble, depending on tile placement, shares its Latin origins with the words quantity, quantify, and quantum, as in quantum physics. It defines this process of reducing the available number of options that allows us limited humans to make sense of the world of infinities that surrounds us. Our whole modern society is built on the quantization done by our cultural ancestors. Take something as simple as the digits 0 through 9. Each one of these can represent an amount of something in the real world, like a ping pong ball. For each digit 0 through 9, I can place an additional ball in the bowl until I reach 9 balls. When it comes to placing the 10th ball, I have no more digits in base 10 math to describe this kind of group. Rather than having an infinite number of digits to represent all possible numbers big and small, I resort to a small, limited quantity of digits that are organized into groups. The quantization of our number system allows us to simplify mathematics to the point that it is actually possible to teach, learn, and use in science, technology, and engineering. Imagine the impossible task of something as simple as addition if every possible value was assigned its own digit. Something like 25 plus 30 equals 55 would become squiggle plus robot head equals alien invasion. But it's not only math and number values that require quantization. All written language is quantized. In the English language, only 26 letters are needed to construct any word. Other phonetic languages may have more letters or accents, but still employ a limited alphabet. Even character-based languages like written Chinese or Japanese are quantized, with many of the more complex words being constructed of simple single-character terms. And while not perfect, quantization gives us the ability to simplify the world in a way that it can actually make sense. Take, for instance, the distance between Los Angeles International Airport in Los Angeles, California, and John F. Kennedy International in New York, New York. The straight line distance between the two is about 2,435 miles, but this precise number is actually rather useless because it would require tunneling through the Earth. A much more useful distance as the crow or airplane flies is 2,475 miles airport to airport. On the other hand, if I were to drive the distance between the same 2 points, I would have to travel between 2,810 and 2,850 miles because of the indirect path of the roads traveling across the United States. If you were to ask me the distance between the 2 points, I could tell you that the distance is 3.98 times 10 to the 15 nanometers, 0.62 Earth radii, 26.6 microastronomical units, 421 picolight years, or the wavelength of electromagnetic radiation oscillating at 75 Hz. While not infinitely perfect, the quantization into miles or kilometers is good enough for most needs when dealing with such a distance. On the other hand, a basic quantization into miles or kilometers would be wrong when looking at the wavelength of visible light, the distance between bits of information on a DVD, the size of the solar system, or the distance from Earth to Alpha Centauri, the closest star to our planet other than the Sun. The accuracy of any quantization is largely dependent on its frame of reference, or in other words, how much detail we're actually looking at. Take something like the concept of straightness. At a normal viewing distance, the edge of this piece of paper appears to be straight, but under a microscope, it suddenly appears rough and jagged. Infinite perfection is beyond human comprehension and what we can achieve with technology. And so, to work within this world and make sense of it, we limit our need for perfection and settle for quantization. Even the most important moments of our lives are mediated through approximations, like the phrase, "I love you." Saying these words to your significant other alone does not convey the depth of your feelings, and yet, when coupled with a deep, longing look into their eyes, such a quantization is often good enough. For Tech Laboratories, I'm Tech Adam saying, keep thinking, and thanks for watching. Have a question about today's episode? Ask it in the comments or on Facebook and Twitter, and subscribe for more weekly science and technology videos. By smashing a hard rock together with a soft rock, a piece of bone, or wood, the toolmaker was able to chip off pieces of the softer substance and modify it into the desired shape.